Students, let's continue the chapter force and laws of motion. With respect to this chapter, in the very first period, we got the basic information, maybe the definition of force, unit of force, what type of physical quantity it is, nature of forces, then effects of forces. In addition with that, even we come across the two important types of forces. One is balanced forces, second one is unbalanced forces. Then after that, we started focusing on the laws of motion. Among them, the first one was the law of inertia that we were discussing, right? Even I had given you the statement of the first law of motion. Yeah, just we shall recall only few important points which we discussed in yesterday's class. The main concept that we had covered was inertia. You all know that inertia, it is the tendency of a body which opposes or which resists the change in its state of rest or of uniform motion. It avoids, it quite will oppose the change in the state of rest. That is, it avoids changing the state of a body from rest to motion. Then if the body is moving with a constant speed, again it will oppose to change that speed. Even it will oppose to bring it to rest also, right? That is what we say inertia, and clearly it can be defined as the property of or the tendency of a body which opposes the change in the state of rest or of uniform motion of a body. In inertia, how many types are there? 3 types. Dhanush, what are those 3 types?
Sir, unmute your audio.
It is inertia of rest, second one inertia of motion, third one is
inertia of direction.
The tendency of a body which opposes the change in state of rest. What it is called?
Inertia of rest.
Inertia of rest.
Inertia of rest.
Body which opposes the change in state of
Inertia of motion.
Inertia of motion.
tendency of a body to resist or which opposes the change in direction of motion of a body. What it is?
Inertia of direction.
Inertia of direction.
Direction. Imagine that you are sitting in the unmoving bus. What happens when bus starts suddenly? Whether
It
you
fall back.
forward or backward.
Inertia of rest. Inertia of rest.
Reason for this?
Inertia of rest.
Inertia of rest.
Rest. Even I had given you the explanation for that. When bus starts suddenly, the lower part of our body, as in touch with the floor of the bus, it will also start moving. On the other hand, the upper part of our body will have a tendency to maintain the same state of rest. Hence, we lean back. Right? Similarly, when you are in the moving bus, when bus stops suddenly, what happens?
We fall forward.
Forward. You will fall forward. You may bend forward, right? Then what is the reason for this?
Class started.
It is due to inertia of motion. And explanation for this, when bus stops suddenly, as the lower part of our body is in touch with the floor of the bus, it will also stop. Whereas upper part of our body has a tendency to move continuously. Hence, we lean forward, right? When you are in the moving car or moving bus, if the bus or car takes sharp turn towards left side, what happens to you?
We fall right side.
Towards right side.
Inertia of motion. Direction.
Due to
Inertia of direction.
Got it? When you are moving in a straight line, your body will have a tendency to move in the same direction. As it takes left turn, as your lower part of your body is in touch with the floor of the car or bus, it will change the direction. Whereas the upper part of our body has a tendency to move in the same direction. So we will move aside. If it takes sharp left turn, we move towards right.
Right.
If it takes right turn, we move towards left. Right? Okay, similarly, when the branches of the tree are shaken vigorously, the leaves will fall. Reason? It is due to
Inertia of rest.
inertia of rest. Leaves are at rest. As we shake that vigorously, they lose their tendency to maintain the same state of rest. They get detached from the tree, hence they fall. Right? Similarly, assume that you have taken a carpet. In that dust are there. You have to clean it. What you'll do? The most common method is we will take the carpet and hit that to the wall. We never consider whatever the wall it may be. Just we'll go for hit that to the wall so that dust will fall. But we'll go for taking a situation that
Inertia of
remove
rest.
the dust particle present in that carpet, with a long carpet, it is to be hanged. Then by hanging it, then you'll go for beating that with a stick. Then the dust particles will start falling down. What is the reason? It is
Inertia of
inertia of rest. How it is? Let me explain. Look here. Look here. Look here. Here, this is hanging carpet, which consists of the dust particles. What is the state of dust particles? They are all at rest.
Rest.
When you beat with a stick, then it starts waving. Wave ಆಗ್ತಾ ಇರುತ್ತೆ. Then when you hit that, one part will go inside and other part will come up. Here, as the dust particles are there here, dust particles, they have a tendency to maintain the same state, but there is no support for them. Hence, the dust particles will fall. Clear up? It is due to inertia
of rest.
And one more, you'll go for taking a cup and take a cardboard and place it on the cup, and take a coin, place it at the middle of the cardboard, and flick the cardboard with a greater force. Whether coin moves along with the cardboard or whether it falls into the cup.
The coin falls into the cup.
Falls into the cup.
Due to inertia
Of rest.
the coin ಅಲ್ಲೇ ಇರುತ್ತೆ, but there is no support for that, hence it will fall. ಅಲ್ಲೇನೋ support ಇದ್ರೆ it will be there only. Got it? ಅದಕ್ಕೆ ನೀವು ಇನ್ನೊಂದು best activity ಮಾಡಬಹುದು ಅಂದ್ರೆ, you can conduct this activity at home only. Here, a cardboard is there, and you are good. Then you go for placing a paper, a sheet of paper. Cup is taken, on that we have placed a cardboard. Then on that you have placed a paper and place the coin here. Then pull the paper quick as possible. Whether coin comes along with the paper? No. So it will be on the cardboard. It is due to inertia of rest. Clear? Any doubt?
No, sir.
Any doubt?
No, sir.
No, sir.
No. Okay. Based on all these information, we define the first law of motion, that is law of inertia. According to this law, every object or every body continues in its state of rest or of uniform motion in a straight line unless it is disturbed by an external force. Jaknur, have you got it?
Sir,
Have you got it?
sir, I have a doubt, sir.
You are busy with your brother, I think. Yes, tell.
Yes, sir. Sir, when leaves detach from the tree, sir, on vigorously shaking, Why it is called inertia of rest, no sir? Why it is called so, sir? External force we can call, no sir?
Because of that external force only, it will lose its strength. Got it? That is why it will fall. As
Strength.
it was at rest. Before shaking, it was at rest, right? And on shaking, it will lose its strength. Hence, it will start losing a tendency to maintain the state of rest. That is why it gets detached.
Yes, sir.
Got it? Now, we'll move on to the next part of this chapter.
Chandana, you concentrate, don't concentrate somewhere. Can you please explain once again what Raju sir told just now? That is what I am telling. Please concentrate. Clear?
So, shall I continue?
Yes, sir. Yes, sir.
Okay. Dear students, just we'll move on to the next concept. Observe this carefully. Look at the book. Fahim. Let your concentration should be here. Fahim. Look here. You are going to take two objects. One is a cork ball, cricket ball. Another one, shot put of same size. This is better new leather ball, and this is
Short.
iron. What is the state of these two objects?
Rest.
Rest.
How long they will be at rest?
Until external force is
Until
applied.
we do not disturb.
The external force applies.
Till then, both will be at rest. Right?
Yes, sir.
Which one of these two has more tendency to maintain the same state of rest?
Iron.
Iron.
Then
Iron.
what do you call the tendency of a body to maintain the same state of rest?
Inertia of rest.
Inertia. Because both of us having inertia or anyone?
Both are
Both are having inertia.
Inertia. Which one needs more force to display?
Iron ball.
Right? Why it is so?
It has large mass.
Mass of iron is greater than mass of lead, right?
Yes, sir.
Can we say that as iron needs more energy or more force for displacing, whether it is maintaining the more inertia?
Yes, sir.
Yes, sir.
More inertia. Iron. Is there any relationship between inertia and mass? Inertia and mass.
Directly
Directly proportional, sir.
Directly proportional, which means as the mass increases, inertia also increases. Inertia is directly proportional to mass. And we also know that the minimum force required to displace an object is called, what is that? What it is? Minimum amount of force required. That is 1 Newton. Frictional force. To overcome that frictional force, we have to exert some amount of force, and that force can be measured by using the device called
Spring balance.
Spring balance.
Then look here. Here, can we say that mass is the measure of inertia?
Yes, sir.
Yes, sir.
So, if ಜಾಸ್ತಿ ಇದ್ರೆ mass will be more. If inertia is less, mass will be less. Hence, we can say that mass is the measure of inertia. This is the relationship between mass and inertia. Inertia is directly proportional to mass. As mass increases, inertia increases. Mass decreases, inertia decreases. Now let me give you again two more objects. Bike and bicycle. Both are at one place. Which one has more inertia?
Bike.
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 Bike and car.
Car.
Car and bus. Which one of these has more inertia? Bus. Why it is so?
It has
So
more
because
mass.
Mass.
Yes, more mass.
More than the mass of the car. Therefore,
Car and bus.
it has more inertia. And bus and lorry.
Lorry, sir.
Lorry.
Lorry and truck.
Truck.
Truck and train.
Train.
Train have more inertia.
Train and jet.
Train and helicopter.
Train and aeroplane.
Train and aeroplane.
Airplane and cargo plane.
ಇರ್ಲಿ ಬಿಡಿ, ಅದೇ ಬೇಡ.
Cargo plane.
ಗೊತ್ತಾಯ್ತಲ್ಲ? The relationship between mass and inertia is mass is the measure of inertia. Mass is the measure of inertia. ನೀವು inertia ನ measure ಮಾಡ್ತಿದ್ರಿ ಅಂದ್ರೆ ಅದಕ್ಕೆ ಅಷ್ಟು mass ಇದೆ ಅಂತ. And inertia is directly proportional to mass. Then what is the unit of mass? Yes, a unit of
kg,
mass.
sir. kg.
Kg.
Nothing but kilogram. Okay. What is the unit of inertia?
Kilogram, sir.
Kilogram. Got it? So, please write about the relationship between mass and inertia. Right, did it?
Sir, we were writing laws of inertia, sir.
Inertia and mass. So, mass and inertia. However you want to get it. Inertia and mass.
Sir, is laws of inertia over?
Yeah. Mass of a body is the measure of inertia. Mass of a body is the measure of inertia. So we can also write inertia is directly proportional to mass. For your reference, I am writing as the mass increases, inertia also increases. As the mass decreases, inertia also get decreased. Alright. Then the unit of inertia is kilogram. As the mass of a body is measured in kilogram, even the unit of inertia will also be kilogram. In bracket, you can write kg. Over.
Yes, sir.
I'll give you some of the items. One is iron ball. Second one is tennis ball of same size. Third one is wooden ball. Fourth one is plastic
Rubber ball.
Fifth one is glass. All are having same size. Now my question is, which one has least inertia? Assume that all are
Plastic ball.
Stick ball.
Wait, A, B, C, D, Which one has least inertia?
D.
Maximum inertia?
A.
Could you tell or could you arrange these in the increasing order of their inertia? First term, D,
D.
followed by
D.
E.
C.
D,
E. B. A.
This is increasing order of inertia. Don't copy. I'm Parustini. Increasing order of inertia. Then, says, what is the decreasing order of inertia with respect to these when they are at rest?
A. E. B. C. D.
Reverse order ಬರೆಯೋಣ.
Yes, sir.
Yeah. Right. ಏನಿದೆ ಅಷ್ಟೇ ಬರೀತಾ ಹೋಗ್ಬೇಕು. Right. Iron ball. Next. Tennis ball.
You have to copy that, sir.
Yes, yes. Tennis ball. Wooden ball. Plastic ball and glass. Plastic ball and glass. It is E. Then with respect to this, here I'll write first one. Increasing order of inertia. Increasing order of inertia. Yes. Once you tell. Get it? E. C. B. E. Right? Right. Next point. Decreasing order of inertia. Decreasing order of inertia. A, E,
B, C, D.
and D.
Disturbance.
Excuse me. Amogake, from the yesterday I have been watching you. A lot of disturbance coming from your side. Do you want to disturb the class or you have to learn? Sir, continue.
Finished up? Finished? Now let me go for taking some of the moving objects and objects which are to be moved. Look here. With this, the concept related to first law is over. Inertia is over. Now we are moving to the next part. To know that next part, I'm going to take a situation. In this situation, let me take a wooden plank, sand plank. Just look here. Don't copy anything. Just you have to observe the board. Both are sand plank. Here, let me go for taking 3 balls which are made of different material and having same size. First, let me take a wooden ball. Second one, glass ball. Third one, iron ball. All are to be allowed to fall with the same height. Assume that around 1 meter. From 1 meter height, we are leaving the balls one by one. First, we leave the ball, which is made of wood. When it touches the sand plank, what happens?
It caused depression.
Yes, it creates the depression. Let me show you the depression. That we look at.
Yes, sir.
Even when we allow the glass ball to fall, when it touches the surface of the sand plank,
It has no depression.
it will also create.
Sir, grass ball, no, sir.
Glass.
GLASS. This is wood. This is iron.
Iron.
Next,
So we
third,
should write that, sir.
iron ball is also allowed to fall with the same height. When it falls on the sand plank, again comes to that,
More depression.
More depression, sir.
it creates more depression. Could you tell what may be the reason for this?
It's
Why
mass.
it
Mass.
different
Mass.
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 effect of depressions? Yes, mass.
Because of
As the mass of the body increases and the depression created by it also increases, right? Now, let me go for taking another situation. This time I'm going to use only one kind of ball. First, I'll go for using the wooden ball, and it is to be allowed to fall from 1 meter height. What happens? It creates the depression.
Depression.
I'm going to use the same ball, but this time I'm leaving with the
2 meters.
1.5 meter height. 1.5 meter height. What happens? It creates
Depression increases.
More
More
depression.
depression.
More depression.
Then third one, again same wooden ball is to be taken, and this time we are going to leave it from 2 meter height. When it falls on the surface of the sand plank,
More
it creates
depression.
Depression than second time.
Here,
More
do you say why
Force.
the mass is not responsible in this case?
Force.
Mass and
Force.
height is responsible.
Mass and height is
Mass
responsible.
and
Mass and
height.
Look here. Here we have taken the same object of same size, but we are leaving from the different heights. As the height increases, the speed or the force with which it falls to the ground also increases.
Increases.
Got it? As it increases, it creates more
More depression.
depression. Are you following? Here, velocity of a body is responsible for creating depression. If velocity is more, the depression created by this ball will be more. Got it? In both
Yes,
the cases, objects are moving, but the effect produced by these objects will be different. It depends on the mass and also depends on the velocity. So one physical quantity which can be described by using the mass and velocity, it is the quantity of motion possessed by a body. Do you know what is that?
Momentum, sir. Momentum.
Momentum.
Called momentum. Momentum means it is the effect or the quantity of motion possessed by the body. Under moving object ಎಷ್ಟು effect ಅನ್ನು create ಮಾಡುತ್ತಲ್ಲ, we call that as momentum. In spite it is of same object, but momentum in each case is different. Alva? Same idru kuda the effect produced is different. So the momentum in third case is more than the top, second than first. So actually the meaning of momentum is it is the quantity of motion possessed by a body. And mathematically, it is to be defined like this. Momentum is defined as the product of mass and velocity. And we write the momentum as P. It is denoted by the symbol
P is equal to
momentum.
P is equal to mv.
M into
It is the
V.
product of mass and velocity.
V.
M into B, not plus, into V. P is equal to M into V is the formula used to find out momentum. 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 Spell out the word momentum. M-O.
M-E-N-U-M.
Momentum. Momentum of a body is P is equal to M into V. Product of mass and velocity. It is the definition mathematically. Generally, now define what is it is the quantity of motion of a body or quantity of motion possessed by a body. Then could you tell its SI unit?
Kg meter per second, sir.
kg meter per
kg
second.
meter.
You all know that SI unit of mass is kilogram,
kg.
denoted as kg. Velocity is meter per second.
Meter
M
per
is
second.
to the power minus 1.
Minus
Hence we write kg meter per
meter per
second.
second.
Kilogram meter per second is the SI unit of momentum.
Momentum.
Then whether momentum is scalar quantity or vector quantity?
Vectors.
Vector.
Vector. What is the velocity of the product?
Vector quantity.
Then we'll consider it as vector because it has both magnitude and direction.
Direction.
Now suppose your friend is standing at a distance of 10 meter. How much, Dhanush? 10 meter. Your friend is standing at a distance of 10 meter. You will take a tennis ball and throw it to him. They'll go for catching. What it?
Yes, sir.
First, you will throw the ball with a speed of 5 meter per second. 5 meter per second. Second time, you throw the ball with a speed of 8 meter per second. In which of these two, the quantity of motion is more?
8 meter per second.
Meter per second.
He has thrown the ball with a greater speed, greater velocity. Hangage adru momentum ಜಾಸ್ತಿ ಇರುತ್ತೆ. Momentum in these two cases, second case has more. And you are catching the ball which is coming from the air. You will hit that.
Sky.
Then, and one is coming from a height of about 50 meter and another one is coming from the height of 30 meter. Which one has greater
50 meter.
momentum?
30 meter.
50 meter.
Height of 50 meter. Other the greater momentum of the ಜಾಸ್ತಿ ಇರುತ್ತೆ. Got it? Because the quantity of motion will be more. Yeah.
Sir, what is difference between momentum and acceleration, sir?
It will possess a different momentum. ನೀವು heights ಎಲ್ಲ change ಮಾಡ್ದಂಗೆಲ್ಲ ಅದು momentum will be same. Momentum. ಈಗ suppose here Shreyas Kulambi is asking me a question that we will leave these balls with the different heights, but the depression created by them is same. Under that condition, what will be the momentum of wooden ball, glass ball, iron ball? Depression created is same ಅಂತಂದ್ರೆ momentum will also be same. You know, now ಒಂದೇ ball ತಗೊಂಡು you as we throw it with a different speed, the momentum will be changed. Alva? Got it? So that's why if the depression is created same, the momentum will be same. Depression created is different, momentum will also be different. And Chetan Jaknur, you asked me a question that differences between
Momentum and
acceleration,
acceleration.
alva?
Yes, sir.
Right? ಅದು acceleration ನಮಗೆ ಏನು indicate ಮಾಡುತ್ತೆ ಅಂದ್ರೆ how the velocity of a body is changing with respect to time. Every unit time ಅಲ್ಲಿ velocity ಯಾವ ರೀತಿ change ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ information ಕೊಡುತ್ತೆ. But it will produce, sorry, momentum will give us information about quantity of motion. ಈಗ quantity of an object, it is to be measured in terms of mass ಅಲ್ಲಿ. ಈಗ quantity of a distance ಅಂತ ಅಂದಾಗ you go for measuring the length, breadth. In the same way, quantity of motion, ಅದನ್ನ measure ಮಾಡೋದಕ್ಕೆ we go for using the concept called momentum. That's why we define this as quantity of motion produced by or possessed by a body is called momentum of a body. Mathematically, it is to be defined as the product of mass and velocity. ನಾನು ಹೇಳುವಾಗ ರಿಕಾಲ್ ಮಾಡ್ಕೋಬೇಕು, ಮೈಂಡ್ ಅಲ್ಲಿ ನೀವು ರಿಕಾಲ್ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ನಾನು ಡೆಫಿನೇಷನ್ ಅಂತ ಹೇಳ್ತೀನಿ. Mathematically, we can define the momentum as the product of mass and velocity, and its SI unit is kilogram meter per second, and it is a vector quantity because it has both magnitude and direction. Okay. Then if this momentum is calculated with respect to time, then what it is called?
Change in momentum.
No.
Rate of change in momentum.
Different momentum ತಂದಾಗ change in momentum ತಗೋಬಹುದು. I'm taking with
Rate of
respect to time.
momentum. Rate of momentum.
Very good. Rate of momentum. Rate of momentum ಅಂತ ಕರೀತೀವಿ. Are you all following? Now
Yes, sir.
you are, see that you are going to catch a ball coming from the greater height. When you are catching, you pull back your hand.
Yes,
Got it?
sir.
Assume that you are assume the two positions of your hand. One here, as the ball is approaching, the position of the hand comes here. Avaga time, whether it will be changed or not. Time
Yes.
changes.
Yes,
Will be
sir.
changed, sir.
We have a moving ball. Moving ball antandre it has some quantity of motion, and we call that as momentum. It has some momentum. Following or not? ಅದಕ್ಕೆ momentum ಇದೆ. ಈಗ ನೀವು time ಜಾಸ್ತಿ ಮಾಡ್ದಂಗಿದೆ, what will be the momentum? Momentum ಜಾಸ್ತಿ
Decrease,
ಆಗುತ್ತೆ.
sir.
Decreases.
Decrease.
As the time increases.
Momentum.
Momentum decreases.
Wait.
Inversion.
Rate of momentum is, it is with respect to time. So it is momentum by time. ಈಗ ಟೈಮ್ ಜಾಸ್ತಿ ಆದಂಗಿದೆ ರೇಟ್ ಆಫ್ ಮೊಮೆಂಟಮ್ ಏನಾಗುತ್ತೆ?
Decrease ಆಗುತ್ತೆ.
Decrease.
ನೋಡಿ ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟರ್ ಟರ್ಮ್ ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ರೇಟ್ ಆಫ್ ಮೊಮೆಂಟಮ್ ಡಿಕ್ರೀಸ್. ರೇಟ್ ಆಫ್ ಮೊಮೆಂಟಮ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತು ಅಂದ್ರೆ ಎಫೆಕ್ಟ್ ಏನಾಗುತ್ತೆ? ಡಿಕ್ರೀಸಸ್ ಆರ್ ಇನ್ಕ್ರೀಸಸ್?
Decrease.
As time increases, rate of momentum decreases. As the rate of momentum decreases, effect produced by it also decreases. ನೀವು ಸುಮ್ಮನೆ ಇಲ್ಲೇ ಹಿಂಗೆ ಹಿಡ್ಕೊಂಡಿದ್ರೆ it will come and hit your hand. You may get hurt or you may get bit pain. As you pull back your hand, the time increases. As the time increases, rate of momentum decreases. The effect produced by it also decreases. ಅರ್ಥ ಆಗ್ತಿದೆನಾ? ಮತ್ತೆ don't think like this, sir. We are catching here, instead of holding our hand there, we are holding our hand here. Because of that only, whether it decreases? No. You catch it, you ball illi bantu andre ನೀವು ಹಿಡಿಯಂಗಿಲ್ಲ. You will pull back your hand along with the ball. Ball ಬರುತ್ತಲ್ಲ, ball ಬಂದಾಗ ಅದ್ರ ಜೊತೆಗೇನೆ ನಿಮ್ಮ hand ಅನ್ನು pull back ಮಾಡ್ತೀರಿ. That's why the momentum decreases and effect produced by it also decreases. ಅಲ್ಲ ನೀವು ಅದನ್ನ ಸ್ಪೀಡ್ ಅದ್ರ ಜೊತೆಗೇನೆ ನಿಮ್ಮ ಹ್ಯಾಂಡ್ ಅನ್ನು ಮೂವ್ ಆಗುತ್ತಲ್ಲ, along with the ball only your hand will move with the same speed as the ಹಂಗಾಗಿ momentum ಕಡಿಮೆ ಆಗುತ್ತೆ. Effect motion, the quantity of the motion decrease ಆಗುತ್ತೆ. Clear? Now let me ask you one simple question. There is a bicycle. Let us go for taking an auto. On the path of auto, there is a lemon.
Means what, sir?
Means what?
Lemon.
Nimbend.
Nimbend. Okay.
Then.
Listen. Auto is moving on that. What happens? It
Lemon crushes, sir.
Lemon
Gets
crushes.
squeezed.
Squeezed
Now,
and
there is,
flattened.
we are going to place another lemon. In the same path, a car is coming and it comes very slowly.
Sir, it was squeeze.
Again, it gets crushed.
Yes.
Which of these two effects produced will be more?
Car.
The car.
Car.
Why?
Car.
More
Cause
mass.
the mass.
Auto.
Which of these two has more momentum?
Car.
Auto.
Car is more than that of
Auto.
auto. Understood?
Time consumed is more.
Now, observe it. Again, I'll go for taking the auto in two cases.
Yes, sir.
First time, it moves with a speed of 2 meters per second. Just 2 meters per second. Second time, it moves with a speed of 5 meters per second. In both the time, it will move on the lemon.
Crush.
Of these two cases, momentum will be more.
5 meter per
5 meter per second.
ಜಾಸ್ತಿ ಆದಂಗೂ ಕೂಡ momentum ಜಾಸ್ತಿ ಆಗುತ್ತೆ.
Sir,
Right?
loaded or unloaded, sir?
Very good.
Unloaded.
Loaded is there means more
Listen.
mass.
Observe.
Listen, children. You have a last minute to turn on your video. Some students, they are not ready to turn on their video. I am going to remove. Sir, continue, sir.
Okay. Listen. Let us take the mass of auto as M. First, it moves with some velocity. Then afterwards, it changes its velocity. What do you call the first velocity?
Initial velocity.
Initial velocity.
V.
U.
Second one.
Final velocity.
Final velocity V.
What do you call the product of mass of a body and its initial velocity?
Initial momentum.
Very good.
Initial momentum.
Initial momentum, I take this as P1. Understood?
Yes.
Then
Final
this is
momentum.
Final momentum.
P2.
Momentum.
P2 minus P1. What does it represent?
Change in momentum, sir.
Very good.
In momentum.
P2
Only
minus
momentum.
P1. It is change in momentum. Yeah. It is nothing but mv minus mv. If I calculate this change in momentum with respect to time,
Rate of change in momentum.
Momentum.
minus
m2
Divided by
T. What do you call this? Change in momentum with respect to time.
Force.
force.
Rate of change of momentum.
Time.
Rate
Rate
of
of
momentum.
Rate of momentum. Change in momentum with respect to time.
Force.
Rate of change of momentum. What is
Force, sir,
rate
force.
of change of momentum? Rate of change of momentum. This is equal to, here what is common factor?
M.
Yeah. What will remain?
V minus
U.
V minus U.
V minus U.
What is V minus U by T?
A. Acceleration.
Acceleration.
A.
M into A. This mass into acceleration, we call it as
Force.
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 So, can we say that rate of change of momentum is nothing but force?
Yes, sir.
Sir.
Yes, sir.
Momentum is equal to M into A. M into A is nothing but force.
Yes, sir.
Therefore, rate of change of momentum is nothing but force. As the rate of change of momentum increases, what will be the force?
Increases.
Increases.
Increase.
Rate of change of momentum decreases. Force.
Force decrease.
Decreases.
How do you relate this?
F is directly proportional to MA.
Directly proportional to force. Rate of change of momentum
Momentum.
is
Directly
directly proportional to force applied or applied unbalanced force. This is only
Second law of force.
Second law.
See how simple it is. The rate of change of momentum of a body is directly proportional to the applied unbalanced force, and the change that takes place in the direction of force applied. Now force ಏನು apply ಮಾಡಿರ್ತೀವಲ್ಲ ಅದೇ direction ಗೆ change take place ಆಗುತ್ತೆ. Clear?
Sir.
So second law of motion is also known as
Law of momentum.
momentum. It is also called law of momentum. Newton's second law of motion is also known as law of momentum. Statement of law of momentum is rate of change of momentum is directly proportional to force applied. That's all. Jakno, yes, you are asking.
Sir, in P1 you have taken M into V, no, sir? M into U, no, sir? You can take M into V also, no, sir?
Then it will be negative. Negative, you will get negative force. Negative force means it will be acting in the direction opposite to the movement of the object, like frictional force. Jakno,
that will also come, no, sir? For rate of change in.
definitely, adunu barutte. But
Okay, sir.
that will be taken in the direction opposite to the motion of the object. Ava matra consider.
Yes.
Mass into initial velocity, and this is mass into final velocity. Yes. Now, please write about momentum. Momentum. Right. Side it. Side it in. Momentum. How do you define this?
Product of mass and velocity.
The product of mass and velocity.
That can be defined as product of mass and velocity. But generally,
Quantity of motion. Passing.
quantity of motion possessed
Possessed
by
by
a
a
body.
body.
ಈಗ ಒಂದು ನಿಮಿಷ ಕೇಳಿ. The object, when the object is moving, ಯಾವ ರೀತಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ನಾವು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೇಕಲ್ಲ, ಅದಕ್ಕೆ ನಾವು ಮೊಮೆಂಟಮ್ ಅನ್ನೋದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Got it? Listen, wait. Let me give you again two situations. A bullet is fired from the gun or pistol. Got it? Then from the same distance you throw the ball with a greater force. Which one has greater momentum?
Bullet.
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 So it is very small. It has
Friction.
More velocity.
Right. The quantity of motion possessed by a body. Quantity of motion possessed by a body is called momentum. Is called
Sir, what is
momentum.
the after motion?
Quantity of motion possessed by a body, POCESSED, possessed by a body is called momentum. Now, right, mathematical definition. Mathematically, let me give you the definition. How do you define?
Product
The
of mass and
product of
velocity.
mass and
Mass and volume. Mass and volume.
Product of mass and velocity of a body. Velocity of a body is called momentum. Hope that this chapter is over in your school or going up.
Yes, sir.
Not it started.
going
sir.
on.
Sir, not
Not
started.
yet started.
Is an information for the students who's in your school. If this chapter is started, if this definition is given, please write the same definition in the test or examination to be conducted by your school. Then only you should write. But according to me, this is actual definition and this is mathematical definition. Define momentum mathematically under the product of mass and velocity of a body. Ora? Arushi,
Yes, sir.
have you written?
Yes, sir.
Yes, sir.
Arushi, nowadays yours is passive participation.
Sir.
Arushi, can you hear me?
Yes, sir, I can hear.
Oh. Now, let me write the formula.
Sir, possessed by a moving body.
Manasayal, tell the formula used to find out momentum. Manasayal, can you hear me?
P is equal to
Right.
M into V.
M.
Mass into velocity.
P is equal to MV. M into V.
So, velocity. Symbolically, it can be written as momentum. P
P is
is
equal
equal
to
to
M
P
into
equals to
V.
M into V.
ನಾವು ಗ್ರೀಕ್ ಲೆಟರ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಮೊಮೆಂಟಮ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋದಕ್ಕೆ ರೋ ಅಂತಂದೆ ನಿಮಗೆ ಅದು ಇಟ್ ಇಸ್ ಮಾಡದೇ ಇರೋದ್ರಿಂದ ಜಸ್ಟ್ ರೈಟ್ P1. P is equal to M into V.
Sir, P ಗೂ ರೋ ಗೂ ವ್ಯತ್ಯಾಸ ಇದೆ ಸರ್.
ಡೆಫಿನೆಟ್ಲಿ ಇಲ್ಲಿ ನೋಡಿ ಈಗ ಗ್ರೀಕ್ ಲೆಟರ್ಸ್ ನಲ್ಲಿ ನಾವು ಆಲ್ಫಾ ಬೀಟಾ ಗಾಮಾ ದೆನ್ ಇಂಗ್ಲಿಷ್ ಆಲ್ಫಾ ಬೀಟಾ ಗಾಮಾ ಡೆಲ್ಟಾ ಥೀಟಾ zeta iota tau phi ಅವನ್ನೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಬಟ್ ಇಂಗ್ಲಿಷ್ ಅಲ್ಲಿ A B C D ನೋಡಿ ಈ ರೀತಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಗ್ರೀಕ್ ಲೆಟರ್ ಯೂಸ್ ಮಾಡೋದ್ರೆ ಯೂಸ್ ಮಾಡ್ಬೋದು
Sir, beta means B.
Hey, beta means B angala. Just Greek letters ಅಷ್ಟೇ. Right. ಪೃಥ್ವಿರಾಜ್ ಎಲ್ಲ ಲೆಟರ್ಸ್ ಕೊಟ್ಬಿಟ್ಟೆ ಪೃಥ್ವಿರಾಜ್ ಅಂತಂದೇಳಿ ಗ್ರೀಕ್ ಲೆಟರ್ಸ್ ಅಲ್ಲೇ ಬರೀಬಹುದು. Is it not?
Yes, sir.
Right. SI unit. SI unit is ಹೇಳಿ
kg
meter per second.
Per second.
kilogram. Meter per second. Meter per second.
Sir, in the definition, the quantity of a motion possessed by a moving body, no, sir?
ಈ ಮೋಷನ್ ಅಂತ ಇದೆ ನಮ್ಮ ಹಂಗಾಗಿ ಸರಿ the quantity of motion possessed by a body. ಹೋರಾ over.
Yes, sir.
Sir.
Right. Right. Next numerical problems ಎಲ್ಲ ಇದೆ. Before that, I'll give you the statement of Newton's second law of motion. Right. Newton's second law of motion. Second law of motion. What it is also called?
Law of momentum.
Law of momentum.
Momentum. Bracket law of
Momentum.
momentum. Law of momentum. Let us write the statement. Right. It states that. Put comma. Start with inverted comma. Get it?
Rate of change of momentum is directly proportional to the force applied.
The rate of change of momentum of a body is directly proportional to the applied unbalanced force. Right. Yeah, certainly. Adine yake ante ಹೇಳಿ. Right. The rate of change of momentum of a body and momentum change ಆಗಬೇಕು ಅಂತಂದ್ರೆ should it be balanced force or unbalanced force?
Unbalanced.
Unbalanced.
ಮಾತ್ರ ಸ್ಪೀಡ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ನೀವು ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಸ್ಪೀಡ್ ಎಷ್ಟಿತ್ತು ಫೈನಲ್ ಸ್ಪೀಡ್ ಅಷ್ಟೇ ಆಗುತ್ತೆ. Right. The rate of change of momentum of a body is directly proportional to says continue
Applied.
proportional to the applied unbalanced force
In the direction of force.
and ಹೇಳಿ ಈಗ
It acts in the direction of
force.
ಚೇಂಜ್ ಆಗುತ್ತೆ. ಆ ಚೇಂಜ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಗೆ in what direction
force-
that change takes place?
the direction of the force it acts.
The direction of
The
force.
direction of force applied.
Direction force.
ಗೊತ್ತಾಯ್ತಾ? ಈಗ ನಾವು ಈಗ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಇದೆ ಅದನ್ನ ಪುಷ್ ಮಾಡ್ತಾ ಇದೀವಿ. The object moves in the
Direction
same
of
direction. ನಾವು ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿರ್ತೀವೋ ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗುತ್ತೆ. Got it?
Sir.
Right. And the change takes place in the direction of force. In the direction of applied unbalanced force, or just force, the direction of force. This is another important law of law of motion given by Newton. Prithvi, have you written? Sit properly, sit upright. He's sitting in the cushion chair and taking rest.
Sir.
Prithvi, sit properly.
Excuse me, sir.
No need to see anybody. Just focus only on the board. Amog. I'm okay. Once you go through the statement, the rate of change of momentum of a body is directly proportional to the applied unbalanced force, and the change takes place in the direction of force applied, or just force. You mathematically ಬರೆಯೋದಾದ್ರೆ they will ask you give the mathematical expression for Newton's second law of motion. Okay, ಗೊತ್ತಾಯ್ತು ನಮಗೆ. Rate of change of momentum is
Product of mass and acceleration.
force. That is, force is equal to
MA.
Just observe.
M
Force is
into A.
equal to M into A. ಇದನ್ನ ನಾವು ಡಿರೈವ್ ಮಾಡ್ತೀವಿ ಮತ್ತೆ. This is mathematical expression for Newton's second law of motion. The mathematical expression for Newton's second law of motion is F is equal to M into A. Right. Side heading. Mathematical expression for second law of motion. Okay. F is equal to M into A. F equal to M into A. ನಿಮಗೆ ಮತ್ತೆ ಕ್ವಶನ್ ಏನ್ ಕೇಳಬಹುದು? They'll ask you the question like this. Derive the equation F is equal to M into. Or derive an equation.
Sir, what is the full form of MA?
Yes, yes.
Full form of MA.
Mass into acceleration.
No.
Acceleration.
Mass into
Mass
acceleration.
into acceleration. Rajit, clever boy.
MA.
MA.
Ora.
Yes, sir.
Derive this equation. Equation and derive it.
Sir, can we control inertia and momentum, sir?
Once you ask,
Can we control momentum and inertia, sir?
control means just you can reduce only. Controlling it, because if the mass is changed, you can change the momentum. If velocity is changed, you can change the momentum. He is asking that can we control the momentum? Possibilities idena? Ide. Suppose if you are driving the auto with a speed of 10 meter per second, ಹಂಗೇನಾದ್ರೂ ಇದ್ರೆ ಆ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ ಅದ್ರ ಮೊಮೆಂಟಮ್ ಕಡಿಮೆ. Got it?
Yes.
Increase also. Got it? If you are playing, if you are watching a cricket, you can come to know that momentum of one player, it is very slow. Particularly Indian Test cricket team, one fellow is there. All a ball ತಾಳ್ತಾನೆ and he scores very less.
Pujara.
Momentum is less.
Yes.
Yeah, Cheteshwar Puja.
Yes, sir.
ಬಾಲ್ ಆಟ ಆಡಿದ್ರೆ 1 ರನ್ ಹೊಡಿತಾನೆ.
Yes, sir. 28 runs.
Simply for the sake of fun I told. ಈಗ ಯೂಶುವಲ್ ಆಗಿ ನೀವು 2020 ಮ್ಯಾಚ್ ಅಲ್ಲಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಕಾಮೆಂಟೇಟರ್ ವಿಲ್ ಬಿ ಯೂಸಿಂಗ್ ದ ವರ್ಡ್ ಮೊಮೆಂಟಮ್ ಪ್ಲೇಯರ್. He is very good momentum player. Chris Gale, if he comes, they'll tell that he is a very good momentum player. ABD. ಅವ್ರು ಬಂದ್ರೆ ಹೇಳ್ತಾರೆ. ಚೇತೇಶ್ವರ್ ಪೂಜಾ ಬಂದ್ರೆ.
Yes, sir.
Very bad momentum player.
Very bad momentum. We must have the knowledge all around. ಗೊತ್ತಿರ್ಬೇಕು. ಕ್ರಿಕೆಟ್ ಬಗ್ಗೆನೂ ನಾಲೆಡ್ಜ್ ಇರಬೇಕು. You have to watch cricket, but it should not be your life, because some fellows will be there when they start watching the cricket, even they will also watch the test match each and every ball.
Yes, sir.
Right.
Sir, what is
Right.
Sir.
Derive the equation. Derive the equation. F is equal to M into R. Derive the formula to calculate force using Newton's second law of motion. Using second law of motion. ಈ ರೀತಿನೂ ಕೇಳ್ಬೋದು. Now Observe.
Excuse me,
So
sir.
that it is, we have to derive the equation F equal to m into a. In acceleration ಬೇಕು ಅಂದ್ರೆ what should be the velocity of the body? Should it be same or different? Different. ಅಂದ್ರೆ
Different,
initial
sir.
velocity ಗೊತ್ತಿರಬೇಕು, final velocity ಗೊತ್ತಿರಬೇಕು. So right. Here, I consider an object whose mass is m.
Sir, we should draw.
Yes, you must. Consider a body of mass m and assume that it is moving with some velocity. Call its velocity as u.
U.
ಈಗ ಇದು velocity change ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು?
ಇನ್ನು ಸ್ವಲ್ಪ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೇಕು sir.
The force ಅನ್ನು ಅದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡಬೇಕು. Then when force is applied on a body, then it changes its velocity from u to v.
V.
Or not? This figure should be drawn.
Sir, not understood.
Alpet, think that you are riding a bicycle.
Yes, sir.
If you want to increase the speed of the bicycle, what you'll do?
Sir, I will ride the bicycle
Start pedaling
faster.
more. Andre you are giving external force in the form of pedaling. Hangene ಇಲ್ಲಿ velocity change ಆಗಬೇಕು ಅಂದ್ರೆ we have to apply the force. Due to the application of force, the body has changed its velocity from u to v. Hangandre to change the velocity from u to v, will it take the time? Yes. What is
Yes,
the
sir.
time? T seconds ಅಂತ
T.
right up. Consider m is the mass of a body. Mass of a body. Then what is u? Please go on writing with me.
Initial velocity.
Initial velocity.
Initial velocity. Initial velocity of a body. Just you can write initial velocity. Then v.
Final velocity.
Final velocity.
Final velocity. Why it takes final velocity?
Due to
the force. The
Yeah.
force apply ಮಾಡ್ತೀವಿ. Then to change the velocity from u to v, it takes time. I'll write this as t. Time take. Then f is
Force. Force applied.
Force applied. Alright. Next.
Sir, in initial
The momentum of a body, we know that it is the product of mass and velocity. Here, as the body has changed its velocity from u to v, it has its own initial momentum, and due to the application of force, it has changed its momentum. We can call that as final moment.
Yes, sir.
Understood or not? Right.
Yes, sir.
Initial momentum of a body. Initial momentum of a body. Hey, bigger.
Mass into initial velocity.
M into u. ಅದನ್ನ P1 ಅಂತ ಅಂದ್ರೆ P1 equal to M into u. ಅಂತ ಬರೀ. ಡೈರೆಕ್ಟ್ ಬರೆಯೋದಾದ್ರೆ just mu. Next.
Final momentum of a body is mv.
Yes.
mv.
Very good.
M into v.
Final momentum of a body. It is m into v. Next.
Change in momentum. Change in
Change in
momentum.
momentum.
Change in momentum ಬೇಕು. ಯಾಕೆ ಹೇಳಿ? According to Newton's second law of motion, the rate of change of momentum ಬೇಕು, ಅದಾದ್ಮೇಲೆ rate of change of momentum ಬೇಕು, right? Change in momentum of a body. ಹೇಳಿ.
mv minus mu.
mv minus m. Next.
M common.
ಹೇಳಿ.
Rate
Rate
M
of
common.
Change of momentum.
momentum of a body. It is
MV minus
as
M.
common.
minus mu.
Divided by T.
One student said that m can be taken as common factor.
V minus U.
V minus U by
Minus u by
Divided by T.
what is v minus
M.
u by t?
Acceleration.
Acceleration.
M A.
Equal to
M
v
A.
minus u by t. This is rate of change of moment. Using Newton's second law of motion. What is that?
M into A.
According to Newton's second law of motion, let's tell that
Rate of change in momentum is equal to force applied.
Force into
rate of change of momentum
Is equal to 4.
equal is
Directly
directly proportional to
Applied force.
Applied force.
Force ಅಂತ ಬರೀ.
Yes, sir.
Then could you tell what is rate of change of momentum?
MA is equal. MA is
MA.
proportional
A
to
is
F.
directly proportional to
A
F.
is directly proportional. Force. It is. Yes. Understood?
Yes, sir.
MA is proportional to F. This can also be written as F is proportional to MA. What is this symbol?
Directly proportional.
Proportional. ಈಗ proportional ನ remove ಮಾಡ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು?
One constant ಕೊಡ್ಬೇಕು sir.
Very good.
By
You have to assume proportionality constant or constant proportional. ಅದನ್ನ assume ಮಾಡ್ಕೋಬೇಕು. Here F is equal. Proportional ನ remove ಮಾಡ್ತಾ ಇದ್ದೀನಿ. F is equal to K into MA. What is K?
constant.
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 Proportionality constant. Proportionality constant. ಅಥವಾ constant proportional. Over.
Yes, sir.
Listen. Listen. If mass of a body is 1 kg, acceleration is 1 meter per second square, then what will be the force?
1 unit, 1 Newton, 1 Newton.
1 unit, alwa 1 Newton. So that is why in place of K, I go for taking 1. If I take 1 in place of K, what it will be? F is equal to
F is equal to
M into A.
right. F is equal to MA because K is 1. Constant along.
Yes, sir.
F is equal to M into A. Hence, the equation is derived. Our formula is derived. I don't have space. I am writing here. But you have to write below that form. Samarthyan V. Yes, you are so tired.
F is equal to K into
Yeah.
is
Therefore, hence the equation is derived. Hence, the formula is derived. The formula is derived. How much marks you will expect?
3 marks sir.
3 marks.
4 marks.
100% ಕೊಡ್ತಾರೆ. Some derivations are common. ನೀವು equations of motion ಗೆ ಬಂದ್ರೆ any one of those 3. ಇಲ್ಲಿ ಬಂದ್ರೆ
Sir,
they give F equal to M into A.
Sir, instead of derive the equation F is equal to ma, they can also prove that F is equal to ma also, sir.
Prove that, no, they won't give like that. They'll just give you the derivation. Dear students, you can also become a question paper setters. Again, some questions are quite common. Ignore physics. So far, we are covering the second chapter. First chapter was about motion. Second chapter is force and
Force and
motion.
large and motion.
You have already come across some of the differences. Alva? Distance and displacement, speed and velocity, acceleration, deceleration. So any one of the differences can be given. Next, you have come across the derivations. Derivations are V equal to U plus AT, S equal to UT plus half AT square, V square minus U square equal to
2as.
equal to M into A. Any one or two can be given. 100% ಕೊಡ್ತಾರೆ. Then we have laws, first law, second law, third law. Among these three, one must be given. But ಇಲ್ಲೇ ನಿಮಗೆ ಕೆಲವೊಂದು sure questions ಗೊತ್ತಾಗುತ್ತೆ. 100% questions to be given in the examination can be guessed by yourself only. ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಯಾರಾದ್ರೂ ಪೂರ್ ಇದ್ರೆ, not financially, knowledge ಕಡಿಮೆ ಇದ್ರೆ ಅವರಿಗೆ ಹೇಳಿ, these are the important questions. Definitely they will come. You go for preparing. Like that you can help your friends. But don't show you are writing in the examination. Please, once you go through the derivation, very simple. This figure is must, because it will give us the information that due to the application of force, a body will change its velocity from U to V. Afraid I am explaining here, you are writing. Very unfortunate. Teacher explain correct ಕೇಳಿಸ್ಕೊಳ್ತಾ ಇರಬೇಕು. ನಾವು ಬರಿಬೇಕು. Then you'll write all the terms. M is the mass of the body. Obviously, momentum ಬೇಕು ಅಂದ್ರೆ mass ಇರಲೇಬೇಕು. Next one. Rate of change of momentum ಆಗಬೇಕು ಅಂದ್ರೆ there must be change in the velocity. So that's why we have to assume both initial and final velocity. To change the velocity from U to V, some amount of force is to be applied. Hence we have written that due to the application of force, body will change its velocity from U to V. To change its velocity from U to V, it takes some time that has been written. After writing all these terms, then you will go for taking initial momentum, then final momentum of the body. Then you will find out the change in momentum. After that, rate of change of momentum, you will get M into A. According to Newton's second law of motion, Lakshmi, what it is? The rate of change of momentum of a body is directly proportional to the applied unbalanced force that has been written. And we know that rate of change of momentum is nothing but MA. Force, it is M. MA is proportional to M. It can also be written as force is proportional to MA. Then we have to remove proportional. Hence we have assumed proportionality constant. That proportionality constant is K. And we also know that if you take one in place of M, one in place of A, F will also be M, K will be 1. Hence K is 1. If I take K equal to 1, then F equal to M into A. So this is the formula used to find out force. What is the unit of force?
Newton.
Other unit can be found out by using this formula. M into A and either. What is the SI unit of mass?
Meter per second square.
Acceleration.
Meter per second.
Other unit of force will also be
kg meter per second square.
Meter per second. Kilogram meter per second square. Arthaita?
Yes, sir.
Yes, sir.
Yes, sir. Okay, that's the information. Okay. What it is?
Yeah.
In
1
1
Newton.
Newton.
Force of 1
1
Newton.
Newton.
When do you say force acting on a body is 1 Newton? ಯಾವಾಗ ಕರೀತೀರಿ?
When 1 kg of mass is
1 kg of
1 kg of mass is accelerated.
Accelerates 1 meter per second
1
square.
meter per second
Then
square.
the force is said to be 1 Newton.
Newton.
The force acting on a body is said to be 1 Newton. Force acting on a body of mass 1 kg is said to be 1 Newton if it accelerates 1 meter per second square. 1 kg ಇರುವಂತ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ನಾವು ಫೋರ್ಸ್ ಹಾಕಿದಾಗ ಅದೇನಾದ್ರೂ 1 meter per second square acceleration ಪಡ್ಕೊಳ್ತು ಅಂದ್ರೆ then we can say that the force acted on that body as 1 Newton. Clear? So next we will go for focusing on solving the numerical problems on F is equal to M into A as well as P equal to M into V. Right? Momentum ಮತ್ತೆ force ಅದರ ಮೇಲೆ problems ಇದೆ. We'll go for solving them. And please do practice the derivation and learn the statements without fail. Okay? And tomorrow you'll be having the online performance test. Syllabus? Force and laws of motion up to numerical problems are momentum as well as force. Stress. I can back ಮಾಡ್ಕೊಂಡೆ. Very good. Complete ಆಯ್ತಲ್ಲ. Close the zip. ಅಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತಲ್ಲಪ್ಪ. ಅದು ಆಗಿದೆ. ನೋಡಿದ. Listen. This is the syllabus. And one more information regarding periodic test. I have already told you the syllabus. Syllabus in mathematics. Number systems, no polynomials. Coordinate geometry, linear equations in two ways. In science, motion,
matter in our surroundings.
force and
Matter in our
surroundings.
Except polynomials.
Practice as good as possible. So with this, let us stop the class. Thank you very much.
Thank
you.